So today we will be doing a problem from the exam kit. It is a combination of single limiting factor and linear programming. So the knowledge of both these are required for tackling this question. So I request all of you to watch the videos on single limiting factor and linear programming and then come and attend this class. So this is the question. CSC company produces cakes, shakes and cookies. So we've got three products. Each product uses two special ingredients, Singa and Beta. So we have got two raw materials named Singa and Beta. Now the details which are given for the three products are the selling price and the cost of Singa and Beta and the other ingredients, the labor, the variable overheads, and they have reduced all the variable cost from the selling price to get the contribution, and the demand of each product is also given. Now, the total fixed cost for the next month are $3,000. Supply of Beta is limited to 12,000 grams. So we have a limiting factor for Beta. CSC company had signed a contract to supply it with 5,000 shakes each month at a discounted price of 5.8 per shake. Now, this is a compulsory contract, which means that whatever be the case, we have to supply 5,000 shakes. And what is the selling price? The selling price of the shake is only 5.8, while the normal selling price is $6 if you sell it in the open market. Now, the order for 5,000 shakes is not included in the above expected demand. So what they are saying is this 5,000 shakes demand, it is not included in the demand of 2,500 given in the table above. Now, assuming that CSC company keeps to its agreement, calculate the shortage of Beta. So Beta, the supply is limited to 12,000 grams. Now we have to find out what is the shortage of Beta. The resulting optimum production plan. So that's the next thing that we have to find out. And finally, we have to find out the total profit for the next month. So there are three things we are supposed to find out. One is the shortage of Beta. Second is the optimum production plan. And third is the total profit for the next month. So I just copied the question extracts relevant to our particular answer so that it will be easier for you to refer to the question. So the first step is to find out the shortage of Beta. Now, what is given in the question? In the question, it is given that each gram of Beta costs $1.5. And for the cakes, $0.75 is the cost of Beta. So how do we find out the quantity of Beta which is consumed for the cake? For 1 gram, the cost is 1.5. And for each cake, the cost is $0.75. So how many grams of Beta have been consumed by 1 cake? So how do we get the answer? It is 0.75 divided by 1.5. That is 0.75 is the cost of Beta for 1 cake divided by the cost of Beta for 1 gram. This is how we find out the number of grams of Beta which is consumed for the cake. So what is the answer? 0.5 grams, which means that each cake consumes 0.5 grams of Beta. Now coming to the cookies. Cookies, it is 0.30 divided by 1.5. You will get the grams of Beta consumed for the cookies. So it is 0.3 divided by 1.5 or 0.2 grams for the cookies. And lastly, for the shakes, it is $1.5 divided by $1.5. That is 1 gram. For the shake, only 1 gram of Beta is consumed. So the quantity of Beta that is required for each product, I will key in this table. So for cakes, it's 0.5 grams. For cookies, it is 0.2 grams. And for shakes, it is 1 gram. So now we have got the quantity of Beta which is consumed for each product. Now the next step is to find out how much Beta is required for CSC company. So let's check the demand of each product. The demand of cakes is 11,200, for cookies 9,800, and for shakes it is 2,500 plus 5,000 shakes. So the total demand of shakes will be 2,500 plus 5,000 of 7,500. Now tell me, what is the total Beta which is required for satisfying this demand? One cake takes 0.5 grams of butter. So 11,200 cakes takes how much butter? So it is 11,200 into 0.5, right? So that much butter is required for making 11,200 cakes. So what is the amount? The amount is 5,600 grams. Now coming to cookies. One cookie takes 0.2 grams. And how many cookies should we manufacture? 9,800 cookies. So what is the total butter which is required? It is 9,800 into 0.2. So what is the amount? The amount is 1,960 grams. Now coming to the last product, shakes. Shakes demand is 2,500 plus 5,000 or 7,500 is the demand for shakes. And for each shake, 1 gram of butter is required. So what is the total butter which is required? It is 7,500 into 1, which is 7,500 grams. So that is how I got the butter which is required for each product. So what is the total butter which is required? Just add these three. You will get the total butter which is required for CSC. That is 15,060 grams. And how much butter is available? In the question, it is mentioned that butter is available only to the extent of 12,000 grams. So what is the shortage? Shortage is 15,060 minus the butter which is available, that's 12,000. So you have a shortage of 3,060 grams of butter. Now, in order to find out the optimum production plan when there is a single limiting factor, what is it that we have to find out? Single limiting factor, in this case, it is butter. Butter is limited to 12,000 grams. So we have to find out the contribution per limiting factor. If you have seen my video on the single limiting factor, you would find that whenever there is a single limiting factor, we have to either find the contribution per hour, if hour is a limiting factor, or contribution per kg, if kg is the limiting factor. In this question, it is kg which is the limiting factor. So what should you find? Contribution per kg of butter is what you should find for each product. So let's get to that. So these are the question extracts that I have copied from the previous slide for your easy reference. Now, to find out the optimum production plan, we should find the contribution per kg. What is a kg? Kg or grams? In this question, it is grams, okay? So butter in grams, we've already found out. So I've just copied the details that we've already found out in the previous slide. And first, let's take note of the contribution per unit of each product. What is a contribution per unit of each product? The details given in the question are 2.6, 1.75 and 1. So contribution per unit is 2.6, 1.75 and 1.2. This is something that I've copied directly from the question. So now the next step is to find out the contribution per kg. But in this question, it is not kg, beta is given in grams. So it is contribution per gram. How do we find out the contribution per gram? It is contribution per unit divided by the beta in grams that is required. So contribution per gram is 2.6 divided by 0.5 for the cakes, which is $5.2. And for cookies, it is 1.75 divided by 0.2, which is $8.75 per gram. And lastly, for the shakes, it is 1.2 divided by 1, which is again 1.2. So the contribution per gram is also found out. Now, what is the next step? We can rank the products. So how do we rank it? The first rank will go for cookies with the highest contribution per gram. The second rank will go for cakes. And last rank will go for shakes, which has got the least contribution per gram. So the ranks are cookies 1, cakes 2, and shakes 3. Now, as per our ranking, we should first manufacture cookies, then cakes, and finally, we should manufacture shakes, provided there is adequate quantity of butter. But we have a small problem. What is the problem? First, we have a compulsory order to supply 5,000 shakes. So that's a compulsory order. So first, we have to meet the compulsory order. Only then can we start with the general production. So let's see the details of the compulsory order. Compulsory order shakes, we have to manufacture 5,000. So I've just written 5,000 shakes to be manufactured. And how much butter is consumed for making 5,000 shakes? One shake consumes 1 gram of butter. So 5,000 shakes consumes 5,000 grams. So 5,000 into 1, that is 5,000 grams of butter consumed. which means that out of the 12,000 grams of beta that is available, already 5,000 gone. So what is the balance left? Balance is 12,000 grams, which was the beta totally available, minus the 5,000 grams, which was used for the compulsory order. So balance, we have just 7,000 grams of beta. Now we can start the general production. So the general production, we will be starting with cookies because it has got rank 1. So how many cookies should we manufacture in total? The demand of cookies is 9,800. So maximum we can manufacture only 9,800 cookies. So let's manufacture 9,800 cookies. So general production, and we will just see how much beta is getting used up. Okay. So general production, 9,800 cookies was the demand. So we are going to manufacture 9,800 cookies. Now, can you tell me how much beta is getting consumed for cookies? For one cookie, it is 0.2 grams. So for 9,800 cookies, how much beta is consumed? It is 9,800 into 0.2, which is 1,960 grams, which means that once you complete the production of cookies, 1,960 grams of beta is also gone. So what is the balance left? So let's calculate the balance of beta which is left. So right now we have a total of only 7,000 grams. That is from here. Now already 1,960 grams have been consumed for making cookies. So I'm going to reduce 1,960. Now the balance we have left is just 5,040 grams. Okay. Now going to the next product, and that is cakes, because it has got rank 2. And how many units of cake should we manufacture? Maximum we can manufacture only 11,200 cakes. Okay. And 11,200 cakes consumes how much beta? Now, for making one cake, we need 0.5 grams of beta. So for making 11,200 cakes, how much beta is required? It is 11,200 into 0.5. Okay. So what is the amount? It is 5,600 grams of beta to make the total demand of 11,200 cakes. But do we have 5,600 grams of beta? No. The grams of beta that is available is restricted to 5,040 grams. So how can we make 11,200 cakes? We cannot make 11,200 cakes. So how many cakes can we make with 5,040 grams of beta? This is our next question. So I'm going to just copy this 5,040 into the column of beta use, because that's the maximum quantity of beta that is available. And how much cakes can we produce? One cake requires 0.5 grams. So if you have 5,040 grams of beta, then you can produce 5,040 divided by 0.5 cakes. Or what is the amount? It is 10,080 cakes. Okay. So maximum quantity of cakes that we can manufacture with the balance beta that is available is only 10,080 cakes. So that is the optimum production. Now we cannot produce anything more because we don't have any beta left with us. So I will just make note of the optimum production. So the optimum production, shapes we have already manufactured 5,000. That was a compulsory order. So 5,000 we are manufacturing. And cakes we are manufacturing 10,080. So I'm making note of that too. So cakes 10,080 and cookies 9,800. So cookies 9,800. So this is the optimum production plan where we get the maximum profit when the quantity of beta is limited to 12,000 grams. Now we will go to the next part of the question. That is, what is the maximum profit that we get when we implement this optimum production plan? So now we know these are the units that we are going to produce. So in order to find out the profit, the first step is to multiply with the contribution per unit. So the contribution per unit of each product is given in the question. So let's go to cakes. Cakes contribution per unit is 2.6. So contribution per unit is 2.6 for cakes. And for cookies, it is 1.75. So I have taken note of that too. Now there is a small problem for shape. The general production is sold at $6. But For the Encompass Health, where we have a compulsory order, we are selling it only at 5.8. So what is the discount that we are giving to Encompass? It is 0.2. So the contribution also will have to be reduced by 0.2. So we get a contribution of only $1 from Encompass because of the discount of 0.2 that we are giving to Encompass. So that will be reduced from the contribution as well. So that is a contribution per unit of the special order. So I have written $1 as a contribution per unit for the shakes because that was a compulsory order to Encompass. Now coming to the total contribution. For shakes, it is 5,000 into 1 or $5,000. For cakes, it is 10,080 into 2.6, which is 26,208. And for cookies, it is 9,800 into 1.75, which is 17,150. So we get a total contribution of 48,358. And to arrive at the profit, what is it that we have to reduce? We have to reduce fixed cost. So what is the fixed cost given in the question? It is given that fixed cost amounts to $3,000. So you reduce that. So less fixed cost 3,000 of 45,358. So this is the maximum profit that we can get when beta is limited to 12,000 grams. So we complete the first part of the question. Now coming to the second part. Discuss whether CSC company should breach the agreement. No further calculations are required. Thank God. So we don't need to use a calculator. This is just a theory question. So should we discontinue the agreement? Now, since it's a theory question, we have to apply some logic. Just take a normal case. If you promise something to your friend and you go back on your word, then what will the friend think about you? He will think very bad about you, right? Because you're not keeping your word. That's exactly the case in business also. If you go back on your word or if you do not complete that agreement, you will have a very bad reputation, which means that if you are discontinuing the agreement or if there is a breach of agreement, then you will lose your reputation. So that's the first disadvantage. So what we will do is we will enlist all the disadvantages that comes up if we breach the agreement. So CSC company should not breach the contract due to the following adverse consequences. The first one is loss of reputation. Just as I said, if you don't keep your word, then you lose your reputation. Second, legal consequences. Now, if you breach the agreement, they can ask you for compensation. So all these are involved if you breach the agreement. Next, loss of a confirmed customer. If you discontinue the agreement, you are losing that customer altogether. Do we have another customer to take his place? So this is something that you have to look into before you cancel the agreement. So due to the following adverse consequences, we should think twice before breaching the agreement. Now coming to the third part of the question, which involves linear programming. In linear programming, there is not a single limiting factor, but there are multiple limiting factors. Let's take a look at part 3 of the question. Later, the demand for cakes and cookies has increased significantly to 20,000 and 15,000 units per month. So the demand has increased. Now, however, CSC company has lost the contract, thank God. Okay, and after suffering from further shortages of supply of beta, Singa, and of its labor force, CSC company has decided to stop making shakes. Okay, so now we've got just 2 products. Only cakes and cookies are there, no shakes. Okay, CSC company now needs to use linear programming to work out the optimum production plan for cakes and cookies. Variable X is used for cakes and variable Y for cookies. The constraints and the graph is, so we have the constraints. So Singa, what is the linear inequality? 0.25x plus 0.5 is less than or equal to 12,000 grams. What is this 12,000? 12,000 is the maximum quantity of Singa that is available with us. Now for beta, it is 0.5x plus 0.2y should be less than or equal to 12,500 grams. So beta is restricted to 12,500 grams. Labor 0.1x plus 0.12y is less than or equal to 3,000 hours, which means that the total labor hours which are available with us is just 3,000 hours. And
X should be less than or equal to 20,000 because the demand of cakes is restricted to 20,000. And Y should be less than or equal to 15,000 because the demand of cookies is restricted to 15,000, and definitely XY should be greater than or equal to 0 because it can't be a negative figure. So this is the graph. The Singa's line is here and Beta's line is here. Labor's line is here and the demand of X, that is here, and the demand of Y, that is here. So they have plotted all the linear equations in the graph. Explain the line C is equal to 2.66 plus 1.75y. Where is that line? C is equal to 2.66 plus 1.75y. So what is that line? We have learned that that line is the iso contribution line, which represents the objective function. Those who have a doubt, please go and check the videos that have been uploaded for linear programming. And the area represented by OABCD, OABCD, OABCD. So the area is this area. What is that area which satisfies all the linear inequalities? It is the feasible region. Okay, so let's write the answer. The line C is equal to 2.66 plus 1.75. Y is the iso contribution line and the equation is the objective function. Okay, so since I've already explained this in the linear programming video, I'm not going to explain it again. Now, features of iso contribution line are the further it moves from the origin, the higher the contribution. And all iso contribution lines are parallel to each other. So we have something here, there's a typo. So all iso contribution lines, okay, are parallel to each other. Any point on an iso contribution line gives the same contribution. That is, in this particular line, we know that in a particular linear equation, whatever point you take on the linear equation, it will give you the same answer. So that is what is mentioned in point 3. Any point on an iso contribution line gives the same contribution. And the area enclosed by OABCD is the feasible region. And optimum production plan will be at the edge of the feasible region. Explain how the optimum production plan is found and identify the optimum point from the graph. So how do we find out the optimum production plan? We have learned that we have to keep a scale adjacent to the iso contribution line. So I've kept a scale adjacent to the iso contribution line, and we have to drag it across the feasible region. And the point at which the scale leaves the feasible region is the optimum production plan. So it will either be point A, point B, point C, or point D. So we will see which is the point where the scale leaves the feasible region. So let's drag the scale. Observe carefully the movement of the scale. Which is the point where the scale leaves the feasible region? It is crossing A, it is crossing B, B, and finally C. Okay, so the point at which the scale leaves the feasible region is point C, which means that point C is the optimum production plan. So they have asked you, explain how the optimum production plan is found and identify the optimum point from the graph. So what's the answer? A scale is placed adjacent to the iso contribution line and moved in a parallel movement outwards. The point at which the iso contribution line leaves the feasible region is the optimum point. In this case, we found that it is point C. Now, the last part of the question, explain what a slack value is and identify from the graph where slack will occur as a result of the optimum production plan. So what do you mean by slack? Slack is nothing but unutilized resources. So since no calculations are required, we don't need to calculate. We have to just mention which all resources have got slack or unutilized resources. Now look carefully at point C. Point C is caused by the intersection of the demand of cakes and the labor line, correct? Which means that the line beta is much above C. The line Singa is much above C. The line demand for cookies is much above C. So all those lines which are much above C, that's the optimum production point, we have a slack there. We have a slack for beta, we have a slack for Singa, we have a slack for cookies. Now the meaning of slack has already been explained in the previous videos, so I will not be explaining it here. So those of you who have got a doubt can refer to my previous videos and check the meaning of slack and then come and view this video. Okay, so slack is unutilized resources. Here, the optimum production plan C lies on the labor constraint and the demand for cakes. Okay. Hence, slack is 0 for these two. So for those two, we have slack 0. And for the other constraints that lie above C, that is beta, Singa, we have a slack. And also for the demand for cookie, we cannot meet the entire demand because of the scarcity of labor. Now, labor is a binding constraint. If you recollect what we studied in the previous class, labor is a binding constraint. We don't have sufficient labor to manufacture the entire cookies. Slack is also unfulfilled demand. So here the demand for cookies is unfulfilled. Hence, there is a slack for cookies also. So slack can either be unutilized resources or it can also be unfulfilled demand. With this, we complete the revision kit questions. I'm sure that some of you would have watched this video without watching my previous videos, and you would definitely be left in doubt. So I request you to watch those videos and then come and watch this video. Even after that, if you have doubt, do post it in the comment box below. And if you've understood how this problem has been done, do click the like and subscribe button and do share it with people whom you feel will benefit from the video. So thank you for watching and meet you in the next video.